Today we will be going over lesson 1-4, converting rational numbers to decimals. So again, the title, which you should write at the very top of the right-hand side of your notes, is 1-4, converting rational numbers to decimals. And the essential question is, how are rational numbers converted to decimals? So again, the essential question is, how are rational numbers converted to decimals? Please remember that this is a video, and if you need to pause and rewind at any time, you can. Please make sure you are setting up your notes, or no note style. The right-hand side should again have the title at the very top with the essential question underneath it. Also, please make sure that you include at least the 4 examples within this lesson in your notebook. So you should be taking more than just the examples, but you definitely need to have at least those 4 examples written down. Also, if you hear my dogs barking, I do apologize. I put them outside. They want to come back inside. All right, let's get started with the notes. So we're going to go over a few different vocabulary words that you are going to see quite a bit during the lessons. We are talking, of course, about rational numbers, and that's why this lesson is called Converting Rational Numbers to Decimals. So you're going to see that quite a bit. A rational number is going to refer to all the numbers that are not rational. Terminating decimals and repeating decimals are the 2 different types of decimals we will be working with, and we will be going over those definitions together. So let's start by defining rational numbers. A rational number is a number that can be written as a simple fraction or ratio. So as long as a number can be turned into a fraction, it is considered to be a rational. Because of this, you're going to see that all the rational numbers we work with are actually fractions. And we are going to be converting these fractions into decimals. So again, here's an example of a fraction. And because it can be written as a fraction, it's called rational. And we're going to turn it into a decimal or convert it over to a decimal, which means both 1.5 here and 3/2, because they're the same thing, they're rational numbers. All right, so let's start with terminating decimals. These are the ones that you have probably seen the most. So if we had an example where it said convert 1/4 to a decimal, you would eventually find out that 1/4 is equal to 25/100. Now, if you notice, this decimal ends, right? And that is the definition of a terminating decimal. It's a decimal that ends. So what I mean by that is that here we have 0.25 or 25/100, and there's no other numbers that follow or dots to represent that something is repeating. So a terminating decimal, just like it says, it ends. There's nothing else to it. So if you've been using terminating decimals, something that's going to be new are repeating decimals. Now, repeating decimals, the definition is very similar to the name, right? Something that repeats. So if you look at this fraction here, if we were to convert 1/3, you would find out that it's 0.333, and then these dots mean it just repeats forever. And so when you see this, a lot of the times, you're going to also see that it's going to be written a little bit different. And so what I mean by that is that here it has the dots, but if you don't want to put these dots in the extra numbers, you can just draw a line on top of the number, and that shows that this decimal is repeating. Another example would be if we have, let's say, 0.14, 14, and it repeats, right? So to write this shorthand, you would write 0.14, and you would draw a line going all over 14 because those are the numbers that are repeating. Now, if we had something a little bit different where it was, let's say, 0.25, and then the 3 is repeating, right? Then you would write this. You would have to write the first few numbers, 0.253. And now we draw a line over the repeating numbers. So what number repeats here? That's right, 3. So we would only write the line above the 3. So as you can see, this line is used to represent repeating numbers, and we always write them just above the actual number that repeats. And so again, here's the definition if you would like to write it down. Repeating decimals, they occur when the decimal repeats forever in a pattern. And that's what's important. There needs to be some type of pattern. So even for the one that we have here where it's 0.14, the pattern is that 14 is repeating, right? So just make sure there's always a pattern, and then that is going to be a repeating decimal. Now, if a decimal is not repeating, then it's going to be terminating. If a decimal is not terminating, then it's repeating. So it's going to be one or the other. So let's go ahead and go over some examples together. The first example is to convert 3/8 into a decimal. So if we convert 3/8 into a decimal, let me get my marker here. Whoops. All right, I wanted to get the pen. Okay, so we're going to convert 3/8. So to do this, if you remember, the fraction line or bar just means that it's actually a division problem. So what we're going to do is we're going to divide in order to get our decimal. So when you do your long division, you have to remember what number goes inside and which one is outside. So we always divide the numerator by the denominator, or for some of you, you've been hearing a lot of top divided by bottom. So the top number, which is numerator, goes inside, so 3. And then the bottom number, which is our denominator, goes on the outside, 8. Now we know 8 cannot go into 3, right? It goes in 0 times. So we're going to add our decimal and add some zeros. And you want to make sure you put that decimal right above, right? We want to make sure we don't forget that. So does 8 go into 30? Yes, it does. It goes in, let's see, not twice. 3 times would be 24, times 4 would be 32. So 3 times. 3 times 8 is 24. We subtract. 30 minus 24 is 6. If you're unable to see that, you could have also crossed this out. It would become a 2. You borrow, right? And then 10 minus 4 is 6. So you would get the same thing. Then we go ahead and bring down the 0. And once you do that, we're going to see if 8 can go into 60. It can go in 7 times. So 7 times 8 is 56. We go ahead and subtract. 60 minus 56 again is 4. And again, if that's confusing to you, you could have borrowed, right? And 10 minus 6 is 4. Then we don't have a 0 yet. So we add another 0, bring that down. Sorry for all the colors. I'm trying to get back to my black marker. And we want to see if 8 can go into 40. 8 can go into 40 5 times. So we put a 5. 5 times 8 is 40. We subtract. You get a 0. 0 is what you want. So I put a little happy face. Which means, right, that 3/8 is equivalent or equal to 0.375, or what would that be? 375 thousandths. Another way to do this would be, we just did this long division. Now, if you have a hard time with dividing and you know that it's just something you can't do, we are letting you use calculators. So another way to convert this would be to, inside your calculator, write 3 divided by 8. And if you type that into your calculator, you will also get 0.375. So even if you like to do it this way, like the long division, I strongly suggest that you go back and at the end, just type it into your calculator. It takes a few seconds and you can double check your work. So let's look back at all the steps that we did, because there were quite a few there. Let's see, we had to divide the numerator by the denominator, right? So first you had to know what went first. And if you like to use the top divided by bottom, it works the same way when you put it into your calculator. You put in the top number and you divide it by the bottom number. You're going to also add a decimal and placeholders. So we did that if you're doing the long division. My zeros are the placeholders. And then we just divide like normal. And again, make sure you use that calculator if you're having trouble with it. All right, so example number 2. We're now going to convert 5 3/4 to a decimal. So to do this, you have to take a look at the mixed number first, right? So if you look at the mixed number, there is a whole number. And when we're converting fractions to decimals, we want to keep the whole number the same. So what does that mean? I'm going to write kind of like my answer down here at the bottom. My answer will still have a 5 as a whole number, and I just have to figure out the decimal portion. And that's going to be that fraction part, right? These 3/4. So we're going to go ahead and convert 3/4 to a decimal. So again, top divided by bottom. So 3 goes on the inside, 4 goes on the outside. 4 cannot go into 3, so I write it 0. I add my decimal, and I add my zeros. I go ahead and make sure my decimal goes straight up, and I divide. So 4 goes into 30 7 times. 7 times 4 is 28. We go ahead and subtract. 30 minus 28 is 2. I bring down my 0. 4 goes into 25 times. And so 5 times 4 is 20. We subtract, we get 0, which is what we want, right? And again, if you want to check on your calculator, you would type in 3 first, the divided by sign, 4, and it should also give you 0.75. However, our answer is not 0.75 because our original mixed number had a 5 as a whole number. So what we do is, because we now know 3/4 is 0.75 or 75 hundredths, all we have to do is attach it to the 5 that we had at the bottom. And so 5 3/4 is the same thing as 5.75. If you want to think of it like money, 5 3/4 of a dollar, it would be the same thing as $5.75. So let's go ahead and go over the steps. We had to make sure we keep that whole number, and so that's why I rewrote it down here. Oops, right? We want that whole number. We're going to divide the numerator by the denominator, and again, top divided by bottom. We're going to add the decimal and the placeholders if you're dividing by hand. And then it's always good to check our work with the calculator. If you're having a hard time doing this, I will let you just do this, type it into the calculator, but you still have to show this as the work, because this right here shows us that you understand what operation needs to occur. Moving on to example 3. The question here is 7 4/9 a terminating or repeating decimal? So this question is not asking for us to simply convert it. We also need to decide if the decimal that results is terminating or if it's repeating. So we're first going to convert it and then decide if it terminates or if it repeats. So again, I like making kind of like my little answer box so that I know that I have to include the 7 and then I have to include whatever the decimal part is. So we're going to first convert 4/9, right? So 4/9, and then we're going to decide if it's terminating or repeating once we have our final decimal. So let's go ahead and place the 4 on the inside and the 9 on the outside. And we know 9 can't go into 4, so I add a 0. And I'm going to add my decimals and my zeros. 9 goes into 40. Let's see. 9 times 5 is 45, so 9 times 4 gives me 36. So then I subtract. 40 minus 36 is 4. I bring down the 0. 9 goes into 40 again 4 times, and 4 times 9 is 36. Subtract, and I get 4 again. So as you guys can see, and hopefully you can see what's going on. Something is repeating, right? So we had a 40 up here. We have another 40, and then again, another 40. So every time we are getting ready to see what number goes into it, we end up with 40. And so what this shows us is that it's actually repeating, right? This would be a 4. And so our answer is going to have a decimal that keeps repeating. And again, if it's 0.444 and it's repeating, you can write it as just 0.4 with the line on top. Now, my number did have a 7 as a whole number, so I'm going to write this down here, 7.4, but my 4 is repeating. So to answer this question, right, is this terminating or repeating? What kind of decimal is it? Well, this decimal is actually repeating, right? So it is repeating because that yellow, it's repeating because the decimal 4 continues to repeat. So let's write this in something we can see a little bit better. So this is a repeating, if I can spell. So let me go ahead and erase that. I was doing so well. All right. I can write it. It's right above there for me. Repeating. So it's a repeating decimal. So let's go ahead and go over the steps real quick. First, we had to turn this into a decimal so we could see if it was terminating or repeating. Well, we do that by dividing. And we put in the top and we divide it by the bottom. And since we see that the 4 is repeating, then we know 7 4/9 is a repeating decimal. Now, what if you had to put this into your calculator? You have 2 different options. I think the best option would be to just divide that fraction part, because again, we know 7 is a whole number, right? So you could just put 4 divided by 9, and that would give you 0.44 on your calculator. But when you see that on your calculator, that is going to tell you right away that that's repeating. So you're going to know that you can write it like that. But because we have a 7 up here, then my answer, right, is 7.4 repeating. All right, moving on to the next example. This is actually our last example that we have on this. So this one says find the sum of 6/8 plus 8 4/10. So now it's not just asking us to convert or decide whether it's repeating or terminating. It wants us to actually solve the expression, right? And that's adding a fraction or a rational number with a decimal number. So you have 2 options. You can either turn the decimal into a fraction, or you can take that fraction and convert it to a decimal and then add the decimals together. So let's go ahead and turn that into a decimal, since we've been practicing turning rational numbers or a fraction into a decimal, right? So again, we put 6 on the inside, 8 goes on the outside. 8 cannot go into 6, so we add our decimal and our zeros. We want to make sure we write our decimal right above. And then does 8 go into 60? Yes. 7 times. We subtract. 60 minus 56 is 4. Again, if you cannot see that, then you can oops, that's not a good one. You can cross it out and borrow, and 10 minus 6 is 4. And then you would have had 5 minus 5 is 0. So either way works. Let's see, so we had 4, so we bring down the 0. And 8 goes into 45 times. So 5 times 8 is 40. And then we get that 0 that we're looking for. That tells us we're done. So 6/8 is equal to 0.75. And if you wanted to check in your calculator, you could just divide 6 divided by 8. it should give you also 0.75. Okay, now we have to actually go through and solve the expression that is being given to us, okay? So to solve it, we're going to have to add, so the first one was 0.75, and we're gonna add 8.4. So you can write the decimal. The 4 is to the right, so I keep it to the right. The 8 is to the left of the decimal, so I write an 8 there, and then we add those together. Now, we do have an empty space, so you can write a 0 as a placeholder, and then go ahead and add. So 5 plus 0 is 5. 7 plus 4 is 11. You carry the 1. So we have 1 plus 0 plus 8, and that gives us 9. Now, if for some reason you're having difficulties with adding decimals, I know some of you are, you can also just plug that into your calculator. 0.75 plus 8 and 4/10, and that should also give you 9 and 15/100. Now, the only thing with this is, please note that even though I'm using a calculator with these ones down here, I'm still showing work, right? So you still have to show work. Using a calculator does not mean you get to just leave it blank. So this right here, that would be showing work, even if it's on a calculator. This is also showing work. That lets us know that we can see that you understand how to do the problem. So let's go over the steps. So for our steps, we had to convert 6/8 to a decimal. Once we were done with that, we were able to, well, you had to do that by dividing the numerator by the denominator. And once we were able to add that, we were able to come up with the answer, right? Oh, kind of went too fast. And I do believe that is the last example that I have to work through. And if we go to this very last slide, you will be getting something like this in class to put in your notebook. If you notice, there's going to be fractions that we see a lot of the times. And so there's a nice little chart here that you can look at that has some very common conversions. So for example, 1/2, you probably knew that was 0.5 if you want to think of money like 50 cents. Another one to look at would be like 1/4 is 0.25. 3/4 is 75/100 or 0.75. Like 1/10 is 0.10, 2/10 is 0.2. So notice how these ones, all that are being divided by 10, are pretty much the same thing as a number, but with a decimal on the left. And of course, everyone knows that 1 divided by 1 is 1, right? So this is a nice little chart that you can also put in your notes so that when you take a quiz or you're doing homework, if there's something like this, you can easily look it up and you can have the answer right there without having to necessarily do a lot of work. So now that we've made it to the end of the notes, you do have 2 practice problems that you need to do. And these 2 practice problems should be done on the left page. So your notes should be on the right page. The problem should be on the left page. If Mrs. Galloway, for her classes, if she gives you a different instruction for those questions, just please make sure you follow her directions. For my students, for Mrs. Gildart, you can go ahead and have the notes on the right side and with the examples on the right side. Only the 2 problems that are on Edpuzzle, those are the ones you do on the left. If you have any questions, please let me or Mrs. Galloway know.